Hello and welcome to another video of circuit tutorials. I'm Bjornafar and today I'll show you how to make a zipline in Rec Room with a simple tutorial. First, open your watch, press on your backpack and press use on your maker pen. Now pick up your maker pen and under the tools you press connect. Now let's get wiring. Here are all the circuits we're going to need. Feel free to pause the video to see all the chips and just clone them in one to one. Now, first, press configure on your maker pen and configure your event receiver to interaction volume on use. Stay on the configure tab and configure your other event receiver and change it to update. Now, go back to tools. Press the connect tool and go under the interaction volume. Wire that to the has tag and the other one to has tag. Now, your tag is going to be two different interaction volumes as seen here. You can configure your interaction volume, scroll down and press delete object board because we won't need it. Now under tags, you would then apply 1. That's what I'm going to do for mine. You can name it to whatever. I'm going to clone it and I'm going to change it to 2. So now this one has the tag 1 and the bottom one has the tag 2. Now I'm going to, under the has tag chip, change the first tag to 1 and change the other one to 2. Now wire the has tag input into the output into the input on the OR and wire that into this if chip right here. Now the interaction volume on uses output execution should go to the input of this if chip, and this bool variable is going to be the output of the bool variable is going to be wired into the if chip. Now on else it should go into the other if chip, and on then it should go into this bool variable. Change this bool variable from false to true, so this bool becomes true when we execute it. This float variable will then be input, the output execution from the bool variable will then go into the input of the float variable. Now the float's data, the float, will be wired into this if value, which will go into when this bool will be then wired into the has tag on the 1. Now on then it should be 0, and then on else it should be 1. Now this if chip, wire that into the bool variable. Now wire the then into the float variable, and then wire the sum into the input of the float variable and the output of the float variable back into the add. Now wire the multiply into the bottom value of add, and then the result from this if value goes into the top of this multiply and just multiply it by 1. This will be the speed of how when you go to point A to point B. Now this multiply chip, wire the top value into the delta time on your update, and the value is going to be multiplied by -1. This will then be wired into else. The then will just be wired into the delta time on the update. This will then be wired into the has tag chip. Now this output from the float variable is going to go into this if chip, and the condition on the if chip is going to go to this if value's result, and the greater or equal is going to go into then, and the less or equal is going to go into else. Now this if is going to be wired into the has tag. Now wire the A into the float variable on both the chips, the greater or equal and the less or equal. Now greater or equal should be changed to 1 and less or equal should stay on 0. Now here on the get local player, we're going to wire that into target and the same with the velocity set. Change the multiplier on the velocity set to 0, and now the precision on the set precision chip is going to be wired into the result on the lerp, and the start is going to wire into the first get precision and the second get precision, and you're going to get the precision of the two different objects. Now, if the top one is 1 and the second one is 2, you want the same here, so that this tag is 1 and this one is 2. Now the progress we're going to wire into the float variable. And then from this if chip on else, we're going to wire that into the set position, and then the output of the set position into velocity set. Now, we're almost done. This is one very important step, and I need you to do this or else it will not work. This bool variable's name, same with this one and this one, all share the same name. I would recommend renaming it like I'm going to do now, like Zipline start, and then renaming all of them. So rename all your bool variables, because if they don't share the same name, the data the variables hold won't be the same. I would also do the same with the float variables. I'm going to name mine progress. So now the different variables that I have now have the same name. So all the bool variables have zipline start, and all the float variables have called progress. Now you can then wire the update into the event receiver. If you now space out the two interaction volumes you have, and I then click one of them, I will go to point A to point B, just like a zipline. Now, as you can see, I'm being set above the interaction volume. If you want to change the height of where you go, you can spawn in a subtract chip, and you can then subtract the height. So I could do it by, for example, 0.5. Oh, sorry, my bad. 0.5. There you go. And wire that into the position. Now when I click it, I will be lower down. It will be way more drastic if I change it to, for example, 3. See, now I'm flying under the ground. Hold up. But that's how you change the height. I just want to keep mine the same, so I can just delete the subtract chip. Now this multiply, as I said earlier, this will be your speed. You can set it to lower to make it slower, so 0.1 would be slower, and 2 would be double as fast, and 5 would be 5 times as fast. But 1 is just the default speed. So this is how everything works. So we want to go to a point A to a point B, right? So with the interaction volume on use, that's what we're using to execute when we want to move. With this chip, we can then see which interaction volume we click, and we then check if it's interaction volume number 1 or number 2. If it is, then it's going to start the zipline. But before that, it checks if we're already ziplining. So if we're already ziplining, we're doing this to prevent the spamming the interaction volume. So we won't just reset over and over again, but we will just move, and you can't click the interaction volume multiple times, but only once. Then when you start ziplining, it sets the progress. It checks if it was 1 or number 2 that you pressed. It does this so we know which side you're on by default, so we will know if we should subtract progress or add progress. So the delta time is our speed, and we're then multiplying it by -1 to turn it into a negative value. That's what we're using to subtract our progress. And then will just be default, and then the multiply will then change how fast it will subtract or add. But when we're ziplining, it will then subtract or add our progress, and then depending on which side you're on, it's just checking if it's added and enough to 1, so we're on the point B now, or from point B to A, it checks if we've, have moved all the way to point A. And then if you have, then it will then turn this zipline start to off, so we won't be moving anymore, because this if would then turn false, which means it's going to execute out of else and then nothing happens. Now, if you haven't moved past, it will then set our position to the lerp. I'll explain that in a little bit. And it will set our velocity to 0. The reason I have this is because every time we move, we still have gravity, so we will fall very slowly. It can make it look very jittery and laggy, so putting this velocity set makes it more smoother when we use the zipline. But here, the lerp, it basically gets point A, which is number 1, and point B, which is number 2. The start and end here. Basically how it works is progress is from 0 to 1. So if it's on point 5, it will output the position in between these 2 points. And if it was point 80, it would then output 80% of the, like imagine like a line like point A and point B. And depending on if it's 0 to 100%, like how far we've moved. So we can either add or subtract that depending on how far we want to go. So that's how everything works in this zipline system. You can also add audio if you want to. So if you spawn in a event receiver and configure it to the bool you had named, so mine is going to be Zipline. So as you can find, it will say your bool variable's name and then changed. You can then spawn in a if chip and wire it up like that. Now, on you can then spawn in a audio player. You can spawn in 2 audio players if you want 2 different sounds. But if on else, you could wire that into play and have your audio connected here with either an audio sample or a SFX chip. In this example, I'm just going to spawn in a SFX constant, which is Rec Room's default sounds. I'm just going to find one like this beep. When I wire it into the audio, and this one into the else, so this beep will then play when I exit out of the zipline state. And I want a different sound to when I start ziplining. So I'm just going to clone this SFX and wire that if chip into the audio player, and I'm going to change the beep to this sound, the boot up, and I'm going to make it faster. So now you can hear it when I click this interaction volume, it will play the boot up sound, and when I go out of the zipline state, it will then play the beep sound, as you could hear. Now, it's very important if you have audio that you configure them and set the synced to off and interrupt current sound on if you want the sound to be able to be interrupted. Now you want to unsync it so other players cannot hear it. Now, that's all for this zipline tutorial. If you have any questions, just put them in the comment section, or if you have ideas for other tutorials I should make, please write it in the comment section and I will make a video about it. So, see you next video.